My name is Wayne Seguin. For those of you who don't know, I've been involved with Cloud Foundry since 2011, full-time since 2013, and from 2013, I used to be at a company called Stark and Wayne. From 2023, I'm now at FiveTwenty, where I'm a co-founder, CEO, and basically FiveTwenty is all about enabling you to build, own, operate, extend, do all of the things with Cloud Foundry, leveraging our particular deep expertise in it. So that's us. You can find me here. So this talk I'm giving on behalf of Kevin, my coworker, who unfortunately was unable to attend today. I hope that I represent his intent of the submission well. The client case study in the presentation was actually delivered by Giannis here. That you see there. So if you have further questions, you can kind of reach out to one or both of them. And so without further ado, let's start this presentation. And we'll start off with a bit of an English language comprehension test. So, so again, without further delay, let's proceed to our discourse. Taming of the Queue is the name of the talk. Hast thou employed the Cloud Foundry app autoscaler? Pray raise thy hand. That's it. If thou hast used custom metrics with the app autoscaler, I beseech thee, keep thy hand aloft. 3, or is that 4? That was 4. Wow. All right. We'll move on from the test. So transitioning from traditional on-premise infrastructure to cloud-based solutions marketh a profound advancement in enterprise technology strategy. The benefits are manifold. Little to no upfront costs, on-demand provisioning of resources, dedicated infrastructure teams, robust internet connectivity, and an industrial-level power supply, always important. Although unplugging data centers may be the challenge there. For businesses and developers, the paramount advantage of the cloud lies in its dynamic scalability. Notably, the on-demand provisioning of resources managed by another's hand. Thus, resources may be adjusted in real time to keep pace with a company's growth or the daily vicissitudes of user demand. Whilst it is possible to scale resources manually, this doth render the process more intricate and significantly prone to errors. To surmount these challenges, behold the Cloud Foundry app autoscaler, CF App Autoscaler, which 4 of you in the room have really used. A tool devised to streamline and automate the scaling process. Now note that a lot of our other talks today are all about the amazingness of Cloud Foundry, but don't forget that there's a vibrant ecosystem that extends Cloud Foundry, and this is one component of it, the CF App Autoscaler. So what is the worth of autoscaling, thou dost inquire? In the realm of cloud computing, the ability to automatically adjust computing resources as needed is of paramount importance. Autoscaling ensureth that applications can handle surges in traffic without requiring manual intervention, thereby maintaining excellent performance and user satisfaction whilst keeping costs in check, if you do it right. It guaranteeth a responsive and flexible infrastructure that can swiftly adapt to changes, which is vital for businesses that seek to truly harness the value of cloud computing. Cloud Foundry's App Autoscaler offereth several key metrics for autoscaling out of the box. CPU utilization scales applications based on the surprise CPU load, ensuring that performance remaineth consistent. Memory utilization adjusteth the number of instances as memory demand varieth, preventing crashes due to out-of-memory errors. HTTP throughput and latency monitors web traffic and response times, scaling to maintain swift and reliable access for users. And last but not least, custom metrics. So the CF App Autoscaler alloweth for the integration of bespoke metrics, tailoring the scaling process to the unique demands of any application. This is the interesting part. So let's dive further, let us discourse further, shall we say, upon these custom metrics. CF App Autoscaler truly revealeth its might with support for custom metrics. This feature permitteth businesses to set their own criteria for scaling, such as specific performance indicators or even business metrics. Custom metrics afford a level of precision and relevance that general metrics cannot, rendering autoscaling more effective and, dare say, closely aligned with business goals. Again, if you do it right. So, for example, what could you do with custom metrics? So one example might be the number of active users or sessions connecting to applications. Some applications might need to scale based on the number of concurrent users, ensuring resources are utilized efficiently. Not all language frameworks can process the same number of active user sessions based on a single process. So those often need to scale much bigger. Another example might be database timings for applications that heavily depend on different types of databases. Monitoring database timings can indicate when additional resources, when and where additional resources are required in order to maintain smooth operations. Another example for certain use cases is error rates. Sometimes we can observe the frequency of errors or specific types of errors and then prompt scaling to enhance stability should the application encounter difficulties. Now, there are also other types of errors where you don't want to scale. You want to fix it. Some other examples include business-specific metrics. Sometimes metrics tied to significant business activities, such as order processing or other types of businessy things, can help scale applications in accordance with the actual needs of the business. A good example of that might be like if you're doing stuff with Shopify and trying to scale there. So response times for specific endpoints. While general HTTP latency, which is the out-of-the-box metric, offers a broad overview of response times, custom metrics can actually allow you to concentrate on particular parts of an application or system connected to, or even systems that are connected to the application or the application connects to that are critical for performance or user experience. And the final example of what you could possibly do with custom metrics, this list is not exhaustive by any means, is scaling based on work queue depth or the amount of work in a queue. So for applications that manage tasks or messages in a queuing system like PostgreSQL, Kafka, RabbitMQ, etc., there's actually tons of them. Scaling based on the queue's depth or the number of messages in a queue to be worked on can efficiently handle sudden increases in workload. Setting up custom metrics typically involves integrating the app autoscaler with a monitoring system that can track these metrics and communicate with the autoscaler in order to adjust resources based on predefined thresholds. The selection of custom metrics is also heavily influenced by the application's design, the critical components impacting performance, and the key business indicators that reflect the application's ultimate success, or what success is defined as for that application. So that's like sort of some example ideas of how you might apply custom metrics, but as I said, we will kind of proceed to explore a brief case study wherein we did implement a auto-scaling based on the specifically RabbitMQ queue depths for a large enterprise. So what's the context? Well, the context of the problem we set out to solve was that one of our large clients was struggling to manage the growth of their applications. They offer a wide range of services to customers, and the demand for these services varied greatly. They were actually being successful, which drove the demand up, so good for them, and gave us a problem to solve, good for us. So at times they lacked sufficient users to fully utilize the resources, so they were kind of over-provisioned, and then whilst at other times during peak periods their systems became so overloaded that they either slowed down, degrading like user experience, or ceased functioning altogether, giving no user experience effectively. And the primary issue that was occurring actually wasn't with the work queue system itself, RabbitMQ itself. which is what they used to process the non-immediate work messages. But with the rapid accumulation of messages and on the demands surging, basically the work queues got backed up, and this had that undesirable side effect. So this indicated a need to increase their system's capacity to handle everything smoothly. So basically this involved one person coming over, tapping another person on the shoulder, saying, hey, go give us more capacity. And that wasn't exactly a good solution. So how did we design our way out of this? How did we get out of this situation with them? So let us now discuss, as you see here, solution design, where we burned the midnight candles to resolve the issue. Our client required a method to automatically add more workers for their applications to process these work queue jobs in RabbitMQ. So we chose to employ Cloud Foundry's App Autoscaler custom metrics specifically to address this challenge. And so what we did is we used what's called the RabbitMQ metrics emitter to establish a system that monitors the number of messages, or that queue depth, awaiting the processing in RabbitMQ. So by adding that piece, this enabled us to track these queue lengths in real time, which is crucial for kind of sort of assessing and responding to the for the performance of the applications working against the queue depth. And after collaborating closely, we developed these custom metrics-based autoscaler solution together. The specific primary metric that we concentrated on was the queue depth, as I've said, defined by, again, the number of messages yet to be processed in the queue. And this metric was used to determine whether to increase or decrease the number of application instances. This approach allowed for precise scaling according to the specific needs of the application work queues as demand fluctuated. Basically, what you're able to do is set specific thresholds, and if it goes within a certain threshold, it will either scale down or scale up based on your definitions, and then you can adjust those thresholds through time to figure out what works for your specific applications and the use cases. And then after we defined these custom metrics with these specific thresholds, we deployed the auto-scaling solution. And then once it was deployed, we effectively beat the daylights out of it with a phase of rigorous testing, trying to create like various real-world load scenarios to try to fine-tune it to see, like using replays and other things to try to adjust the thresholds and the scaling parameters to try to figure out what would work best for their applications, the specific applications, and then ended up, thankfully, ensuring like sort of the scaling that operated smoothly under the actual real-world conditions once we rolled it out. So yeah, so what were the outcomes of that adventure? So the first one is enhanced performance. So the solution directly addressed the primary issue of RabbitMQ queue depths, ensuring that these applications, all the different workloads that they had for those applications against those queues ran smoothly regardless of the load variations. So the actual goal was achieved. We ended up also optimizing resource utilization by adjusting the number of application instances based on actual demand. The end client, if anybody's familiar with chargebacks, saved money and utilized resources much more efficiently. And then sort of the end user of the end client ended up having greatly improved customer satisfaction. The client's services became far more responsive, more reliable, and this was even during the peak load times that took the system kind of sort of offline because it was getting backed up before. This was no longer an issue. Therefore, end user sort of happiness or satisfaction was actually greatly increased, which was a great outcome. And finally, operational resilience. So because it wasn't backing up far enough where the system would basically just grind to a halt, the auto-scaling solution basically took it to a new level of stability for their operations, allowing them to manage the sudden surges in demand automatically. Most importantly, though, was that it no longer required tapping somebody on the shoulder and saying, hey, go add more instances or whatever to try to scale appropriately. For who wishes to be roused from slumber in the dead of night? For the technically inclined among us, let us take a brief look under the hood to fully appreciate the capabilities of custom metrics. Let us examine the architecture of the RabbitMQ metrics emitter specifically, and a demo. Just kidding. So, RabbitMQ emitter, so as you see here on this slide, these are the sort of core components of the RabbitMQ metrics emitter release. The emitter, so left to right, top to bottom, the emitter.go serveth as the principal entry point, handling logging, configuration loading, metrics emission based on RabbitMQ's state and Cloud Foundry service bindings. The config.yaml.erb generateth the configuration file, dynamically inserting deployment-specific values. Again, back to the BOSH releases are easy, talk from earlier. The config.go defineth the application's configuration structure, encompassing connections and interactions necessary for the operations. The cf client.go, you'll never guess this one. It's essential for metrics emission. It manageth interactions with Cloud Foundry's API, hint, hint, for service bindings. Then on the far right top, we got the management.go. This facilitateth direct interaction with the RabbitMQ management API and is responsible for structuring data around queues and virtual hosts, and for executing API requests to gather detailed information on the RabbitMQ virtual hosts environment and the queue metrics as well. And on the bottom right here, the forwarder. This both includes the sort of logaggregator and metrics forwarder both together. This handleth logging and metrics forwarding to Cloud Foundry's logging subsystem, ensuring that metrics are accurately tagged or attributed. Together, these components are encapsulated within a BOSH release, which is easy, enabling organizations to achieve remarkable outcomes and efficiencies in their cloud infrastructure management. Honestly, this kind of sets a new standards for responsive, demand-driven scaling as applied to applications. And for those of you who didn't raise your hands, you should go back home and use App Autoscaler and then raise your hands next time, because it works really well. For those of you seeking a more technically detailed perspective, you may peruse Yannis's RabbitMQ walkthrough, which is linked here on the bottom. It is very detailed and good. So, what reflections and thoughts arise from this adventure we had? This case study hath demonstrated to us, at least, the potent efficacy of the custom metrics in autoscaling strategies. By designing the scaling system to address specific needs and challenges, we attained new heights of efficiency and performance and reliability. This project underscores the importance of flexibility and customization of resource management. We believe that this capability doth set a lofty standard for future endeavors. This concludes our Shakespearean tale of the taming of the queue.